Welcome to my talk, Invisible Costs, Visible Consequences, Rethinking AI's Future. This talk exposes the hidden costs of AI, from data centers' water and energy consumption to the societal risks of cognitive offloading and eroded human connection. While AI can help build smarter grids, greener supply chains, and stronger communities, it also threatens to deepen inequality, accelerate climate strain, and hollow out critical thinking. By looking at both the good and the ugly, we want to ask ourselves, can we build intelligence that truly sustains both people and the planet? My name is Matthew Hawthorn, and thank you to digital leaders for the opportunity to speak. So who are we? We are Informed Solutions. Our business is built around talented teams of dynamic and driven professional problem solvers, creative thinkers, and solution builders who thrive on helping clients meet the most demanding digital transformation challenges. The AI-powered platforms and services we develop help make the world a safer, cleaner, healthier, more inclusive, and smarter place. We work with globally recognized public and private sector brands operating in a variety of sectors, including civil defense, healthcare, sustainable environment, land asset management, and digital democracy. So a little bit about me. My name is Matthew Hawthorn. I'm a senior data scientist at Informed. I have over 5 years experience working across government and private sector, and currently I'm deploying generative AI solutions for a variety of clients, and I love to play guitar. So let's walk through the agenda of this talk. We're going to be looking at both the positive and negative impacts of AI on the environment and society more generally. We'll begin by looking at the environment, how data centers have a substantial impact on the environment, and how companies are working hard to reduce this. We'll also look at the positive environmental impacts AI can have, discussing some of our previous work in this area. We'll then move on to the societal impact, discussing effects on critical thinking and the loneliness epidemic, before discussing the benefits of AI in healthcare, discussing a recent project we completed with MHRA, that's the Medicines and Healthcare Products Regulatory Agency. So let's begin with AI and the environment. AI is increasingly being recognized as a pivotal area of growth, not just here in the UK, but globally. Usage is growing at an extraordinary pace. However, all this demand is reliant on a hidden backbone, large data centers that can process and deliver these AI services. These data centers come with significant requirements, in particular water and energy. Here in the UK, this has caught political attention. Earlier this year, Prime Minister Keir Starmer announced his intention to hugely increase AI capacity by reducing planning restrictions on new data centers. So this is the broader context we're working in. Booming AI demand, huge infrastructure needs, and government ambition to accelerate capacity. This chart shows just how rapidly AI adoption has accelerated over the past few years. Back in 2017, only about 20% of organizations had adopted AI in at least one part of their business. Within just 2 years, that figure had more than doubled, reaching nearly 60%. Since then, adoption has held steady in the 50 to 60% range, and in 2024, it's jumped again to 72%. What's particularly striking is the rise of generative AI. In 2023, only about a third of organizations reported using it, but just a year later, that number has nearly doubled, hitting 65%. So what we're seeing is that AI is no longer an experiment for a few early adopters. It's mainstream, not only across industries, but also across functions within organizations, and generative AI is driving a new wave of acceleration. This increase in usage of AI services is causing additional demand on data centers. Data centers are the hidden backbone of our digital world. From AI to cloud storage, they power it all. But they come with a cost we rarely think about: water. Data centers are incredibly thirsty developments. Primarily, water is used for cooling. Water cooling is often more efficient than air cooling, especially when dealing with the vast amount of heat servers generate. But there's also indirect water use. The water needs to generate the electricity that these centers consume, so their footprint is often bigger than it looks. To give a sense of scale, a mid-sized data center might use around 300,000 gallons of water per day. Large data centers, up to 1.5 million gallons a day. That's the equivalent of the daily water usage of tens of thousands of households. In the UK, data centers are not obliged to report their water usage figures. This leaves the Environment Agency with major blind spots, making it difficult to predict future water usage trends with accuracy. The Environment Agency already predicts a shortfall of 5 to 6 billion litres of water per day by 2055. To bridge this gap, plans are underway to build new reservoirs and recycling schemes, but the costs will ultimately fall on customers. And all of this is happening against the backdrop of hotter, drier summers and aging infrastructure, which raises a question: Can the UK's water supply keep pace with the demands of the AI industry? Here we can see the global data center water usage in billions of gallons per year from 2023 forecasted to 2030 and forecasted a steady increase. So let me ask you a question. How much water is consumed when ChatGPT 4 is used to write a 100-word email? Is it 100 milliliters, 500 milliliters, or 750 milliliters? The answer is 500 milliliters. That's one bottle of water. That's the same amount that ChatGPT 3 would consume in 10 to 50 responses. By 2027, AI usage is expected to consume as much water as which nation? Is it New Zealand, Norway, or Greece? The answer is New Zealand. There's roughly 6.6 billion cubic meters of water, equivalent to two-thirds of England's annual consumption. Data centers aren't just thirsty, they're also incredibly energy hungry. Running the vast number of servers they contain requires enormous amounts of electricity, and this puts the AI boom directly at odds with regional and global net zero targets. Even as more wind and solar projects come online worldwide, the pace of renewable growth is being outstripped by the rising energy demand from data centers and AI workloads. The more we build, the harder it is to keep up. Some governments are already responding. Ireland, the Netherlands, and Singapore have all taken the step of halting new power grid hookups for large data centers. Their concern? Climate commitments and grid stability. In the United States, after 30 years of reducing reliance on coal, there's now hesitation to retire old coal plants. Why? Because policymakers expect they may still be needed to meet the surging electricity demand from AI and data centers. And this leaves us with a critical question. When it comes to growth and the bottom line, will governments and industry be willing to prioritize environmentally conscious AI development, or will sustainability goals get pushed aside? What quantity of emissions in metric tons did data centers produce in 2023? For context, the commercial airline industry produced 131 million metric tons. So, 93 million, 106 million, or 142 million? The answer is 106 million metric tons, not far behind the commercial airline industry. By 2027, AI usage is expected to consume as much energy as which nation? Netherlands, Japan, or Australia? The answer is the Netherlands. That's roughly 134 terawatt hours a year, about half of England's annual consumption. How much electricity in watt hours does a ChatGPT request use? For context, a Google search takes 0.3 watt hours. Is it 0.5, 1.8, or 2.9? The answer is 2.9. That's about 10 times as much energy. So, what can be done? On the industry side, there are three key levers. First, optimize model efficiency. Make AI models as complex as they need to be, but no more. Bigger isn't always better, and efficiency can save huge amounts of energy and water. Second, data centers should be designed with renewable energy in mind from the outset. That means building in areas with access to renewables and even developing renewable generation alongside the centers themselves. Third, transparency is crucial. If data centers openly reported their energy and water usage, governments could predict future demand and strengthen infrastructure before shortages hit. But there's also a role for us, as individuals. We could be more discerning about which models we use. Do we always need to use GPT-5, or could GPT-5 Mini do the job just as well? And even before that, do you need AI at all? Sometimes the fastest and most sustainable option is just a Google search or checking information that already exists. The point isn't to stop AI innovation, it's to make sure the growth is sustainable. Both industry and individuals have choices to make, and together these choices will shape whether AI's future is aligned with our environmental goals. One of the more innovative experiments in data center design came from Microsoft with Project Natick. They deployed a fully operational data center 117 feet below the surface off the coast of Scotland and left it there for 2 years to test the concept. The idea was simple but powerful. By placing the data center underwater, you can take advantage of the ocean's naturally stable and cool temperatures, reducing the need for traditional cooling systems. The project proved not only that underwater data centers are technically feasible, but also they can be logistically, environmentally, and even economically practical. It's a really good example of the kinds of bold thinking and experimentation that are shaping the future of how we approach digital infrastructure. Approximately how much of global electricity is used by data centers? Is it less than 1%, around 3%, or 10%? The answer is around 3%. Currently, where is the largest data center in Europe? Is it in Newport, Wales, Frankfurt, Germany, or Covilhã, Portugal? The answer is Newport, Wales, CWL1 data center. What is a major challenge when switching data centers to renewable energy? Is it the lack of computing power, data loss during conversion, or inconsistent energy availability from sources like solar or wind? The answer is inconsistent energy availability. So let's move on to harnessing AI for environmental good. AI is playing an increasingly important role in addressing global challenges like sustainability and climate change. For example, in climate modeling, AI is being used to forecast extreme weather events with greater accuracy. Google's flood forecasting initiative is a great case study here. It's already helping communities anticipate and prepare for floods before they happen. In the area of wildlife protection, computer vision systems are being used to monitor endangered species and even to detect poaching threats in real time, providing a powerful new tool for conservationists. And when it comes to energy optimization, AI is being applied to smart grids and to building management systems, helping to reduce waste and make our cities more efficient and sustainable. So what we're seeing is that AI isn't just a driver of economic growth, it also has the potential to be a major enabler of positive environmental impact. So now an example of how we at Informed are promoting positive environmental impact through the use of AI. Informed Insight is a cloud-based, AI-enabled platform transforming how Scotland monitors and manages protected ecosystems. The platform integrates satellite imagery, ecological records, and Earth observation data into a single environment to deliver fast, actionable insights. Modelling suggests it could reduce monitoring costs by up to 65% and enable coverage of 60% more protected areas without increasing program budgets. The platform's innovation and impact were recognised with the Environment and Sustainability Award at the 2025 Association for Geographic Information Awards. Critical thinking is defined as the ability to analyse, evaluate, and synthesize information to make reasoned decisions. It's no surprise that those with higher critical thinking skills often do better in school, in work, and are less susceptible to manipulation. In 2011, researchers coined the term Google effect, whereby frequent search engine users retained information less successfully than those who learned information offline. Now, AI has far surpassed just information recall. It can supplement full human cognition. And with the rise of mainstream large language models, digital assistants plan our days, do our work, and answer our questions. We need to question the impact of having AI so entwined in our lives. Arguments for and against the use of AI assistants vary, but broadly, there are two schools of thought. The first school argues that while AI assistants are sold to us as productivity boosters, freeing up time for things we want to do instead of things we have to do, the result is causing us to neglect tasks that force us to reflect and think critically, causing these skills to atrophy and resulting in societal stagnation. On the other hand, advocates of AI use argue that we, as humans, have a limited cognitive capacity, so having AI automate the mundane aspects of life allows us to focus on learning things that really matter, instead of learning how to navigate the monotony of bureaucracy, for example. And this is called cognitive offloading. Given the two schools of thought, ultimately the impact of AI is really down to the user. Generally, if you do end up using the time saved by AI for innovative or creative thinking, the theory of cognitive offloading holds. However, what if you don't? Dr. Gerlich of the Swiss Business Schools conducted research on over 600 UK residents, and he found that there is a strong negative correlation between the subject's use of AI tools and their critical thinking abilities. Knowing this, how would you define healthy AI use? But affecting critical thinking isn't the only impact AI can have. We've all heard of the loneliness epidemic. Is AI a cause or a cure for this phenomenon? Currently, over 7 million people in the UK experience chronic loneliness, with young adults and the elderly most impacted. The issue is bad enough that the UK appointed a Minister for Loneliness in 2018, and chronic loneliness has been compared to smoking 15 cigarettes a day. Ultimately, the more products and services that utilise AI, the fewer human interactions we'll have. 15 years ago, if your to-do list involved going to the shop, calling a customer service line, and ordering food, there would be an element of human interaction in all of these. However, in 2025, all of these processes can be automated to involve no human interaction. Even your food can be left outside your door. We can see how this could lead to a reduction of social skills as well as cause loneliness. In addition, LLMs can create a false sense of connection and companionship. AI may be smooth and glossy on the surface, but they're ultimately a mathematical formula designed to keep you talking, not a substitute for meaningful human interaction. Ask yourself, do you think you'd be happy if the only human-like interaction you had every day was with a chatbot? We spoke about some of the negative impacts AI could potentially have on society, but we'd like to also speak about some of the good impacts that AI could bring. AI is already being used across multiple industries to create meaningful, positive change. It's being used by DeepMind to accelerate drug development, in education for personalized learning platforms that better suit students' individual needs, and helping governments deal with natural disasters. Ultimately, the rapid integration of AI into our lives is a double-edged sword. It's up to us to ensure that we build on the positive momentum and potential of AI while also working to minimize the risks of negative societal impact. Now I'd like to provide an example of a project at Informed that we're all really proud of because of the positive societal impact it promotes. The Medicines and Healthcare Products Regulatory Agency, or MHRA, in partnership with us at Informed, have delivered a world-first application of AI to transform the UK's clinical trial assessment process. Faced with growing volumes of complex applications for clinical trials and a limited pool of highly skilled experts, the project introduced AI-enabled knowledge retrieval and validation tools that streamline assessments, freeing MHRA's expert assessors' time for high-value tasks and improving consistency of decision-making. The new tool reduced good manufacturing practice assessment time from up to 3 hours to under 5 minutes. That's a 95% efficiency gain and saved the equivalent of up to 180 full-time equivalent days annually. This time can be reinvested in providing upstream advice to sponsors, making applications safer and more assessment ready. The initiative aligns with MHRA's 2024 to 27 data strategy and is underpinned by robust ethical AI principles and provides a scalable model for regulators globally. And the way we completed this project was using our 5-stage AI readiness assessment, which provides a structured, evidence-based assessment of the value of AI to your business, your current readiness, and the people, technical, and data capabilities you will need to unlock value at pace and scale. Our expertise at Informed lies in providing service-centric AI proofs of concept that focus on operationalizing AI in complex environments to deliver tangible business value quickly. If you'd like to learn more about the AI Readiness Assessment or about Informed Solutions more generally, please do not hesitate to reach out to the address shown on screen. Thank you for listening, and I hope you enjoy the rest of your day. Thank you.